Problem 57 is asking us to come up with the equation of the entire tangent line to this particular curve here, or this equation, at the ordered pair 1, 4. So first things first, we got to find our derivative. And since we're not explicitly defined, we got to do some implicit differentiation. So here we go, derivative of the first term. Just using the power rule, the 1/2 times 2 just makes a 1, the base stays as an x, and the exponent drops by 1 to a negative 1/2. So, okay, there's the derivative of the first term. Then, derivative of the second term. That negative 1/2 times the 4 there is going to give us a negative 2 out in front. The base stays the same as y. You drop your exponent by 1, so now we're going to the negative 3/2 power, and then times a dy dx at the end of all that. It's really the chain rule with implicit differentiation. Okay. That's the derivative of the left-hand side equals, and now we need the derivative of the right side, and xy is a product. So that derivative will require the product rule. First factor is x, times the derivative of the second, that's dy dx, plus the second factor, y, multiplied by the derivative of the first factor, which is just plain 1. Okay, so there's our derivative here, guys, and we're working on equation of a tangent line. I need to get the dy dx here isolated. So here's what I see. 4 terms here, 2 of which contain the dy dx. I'm going to move this whole term over to the right side. Usually I move the dy dx's to the left, but I already like the fact that this dy dx is already positive, and by moving this negative term to the right, it'll become positive. That means I got to bring this y back over here. So what's that going to get me? X to the negative 1/2 power, got it, and then a minus y will equal, all right, and then we have an x dy dx, and then a plus now 2, y to the negative 3/2, and a dy dx there as well. I'm going to grab that common factor of dy dx and factor it out in front, and then put parentheses there around what's left over, and then divide by it. So here's what I think we got, guys. Dy dx will equal, okay, this left side now becomes my numerator here, x to the negative 1/2 power minus y, and we're dividing by what's left over after we pulled out the dy dx. So that's going to be an x plus 2y to the negative 3/2 power. Now that's a little bit ugly, guys, but it's time to go ahead and start evaluating that to come up with the slope of our tangent line. So dy dx evaluated at the ordered pair of 1, 4 equals, all right, let's see where that gets us. We've got a 1 to the negative 1/2 power. Well, 1 to any power is just 1. That was nice. And then minus our y value, which is 4. Then in the denominator, right here, we've got a 1, and then plus, ooh, this could get a little ugly, we've got a 4, ooh, to the negative 3/2 power. Ooh, I don't like where that is right there. Let's do a little doodling off to the side here, guys. So 4 to the 3/2 power, what that is the square root of 4 and then cubed. Square root of 4 is 2, 2 cubed is 8. So therefore, 4 to the negative 3/2 power would just be the reciprocal of that, which is a 1/8. We also need to multiply that by 2, and a 2 times 1/8 is going to get us 2/8 or 1/4. Ugh, that was not a whole lot of fun. Okay. So where's that going to get us? We got to clean this up, guys. That's a mess. Numerator was pretty easy. That was just a negative 3. Denominator then, 1 plus 1/4 is going to be 5/4. Well, remember, what this fraction really is doing is taking negative 3 divided by 5/4. That's the same as negative 3 multiplied by the reciprocal there, which is 4/5. And we end up with a negative 12/5 right there for the value of our derivative at this point. And what we have found right there, guys, is the slope of the tangent line. Now, that is not my final answer right here, but that's where things sit right now. Okay, so that was kind of ugly, negative 12/5. Now from there, okay, we've got the slope of the tangent, and we already knew the point of tangency right there was 1, 4, so let's go to point slope form and see where that gets us. Y minus your y coordinate, which is 4, equals the slope of your tangent, negative 12/5 times x minus the x-coordinate of your point of tangency, which is 1. Now let's distribute there. We're going to get y minus 4 equals negative 12/5 x, and then a plus 12 over 5. And then I'd add a 4 on both sides, but I'm going to write that 4 as 20 over 5, and that'll give me the common denominator I need to put those two terms together. And this should be my final answer now, guys. Y is equal to a negative 12/5 x plus, that's not very pretty, 32 over 5. That doesn't simplify at all. So there's my answer there, guys, in slope-intercept form. Okay, so that is what we came up with. Yep, and that matches their answer in the solutions manual for problem number 57.